Hi guys, yeah, welcome back to the brand new session of operating system programming concepts. And here I'm going to do today is laboratory number 3. So it's mostly based towards process management. And the learning goals for today is just to understand how to use the for and then how to create the child process by using the system called for, and then like creating multiple children. So this is our basic learning objectives for today. So let's begin. So in exercise 1, it says that make a program that follows a single child process. So and here are some kind of criteria given. So the criteria says that the child has to show his PID, parent PID, and sleep for 10 seconds. So let's go through all this process part by part, like bit by bit. Okay. So yeah, the first thing is, before creating a program, we have to include the header files. Yes. So also, second, we just include the standard library, the header file, and the important thing is like we have to also include, while writing any kind of Unix programming files which uses some kind of system call that uses the system call of Unix, then it has to include also the header file of Unix standard header file. Okay, by including this header file we can make use of all the kind of system calls. So let's begin, and let's create the main function, and the parameters are passed, right? So here we have to pass C, okay, sorry, because here is a double pointer, so we just need the nothing, we just need a double pointer that is pointing towards the variable, the values, I mean the argument values directly. So the child has to show his PID, the parent PID, sleeps for n seconds, right? So here it begins. Let's use this variable, let's declare a variable PID, process ID. Then what you do is you use the system call that is for here, which is loaded in the Unix standard data files. So you check it directly. If PID is to 0, that means it's a child, right? So yeah, here also, otherwise it's a parent. Also here you have to be careful about like something like sleep for n seconds, and n has been passed as a command line parameter. So we are using this to pass command line parameter, and n has to be used as a sleeping seconds. So we use this function to convert the parameters to directly to the integer number. So the parameter that is passed is the first parameter that we pass. Okay, so here it goes like, let's print off function printf. Yeah, then like you print out in the standard output, print out something like this is a child, and it has to show his PID, so PID of child. Okay, then it has to print the parent PID, so it's like PID of the parent, and then you just print it something like this. Now you use the system call that is get PID. Okay, and then secondly for parent PID get PP, similar something like this, right? And it has to sleep, system call to sleep for 10 seconds. And okay, so before the child processes, it asks for the 8-bit number from the user that will be used as his return code. So let's ask for the 8-bit number. And you guys have to understand that 8-bit number starts from 0 to 255, right? So you can enter any numbers that is from 0 to 255, and that's a 8-bit number. Okay, so here it goes, and then you enter the number, then which will be used as its return code. So what it is done is like scanf. So let's declare a variable with that 8-bit number, that's a number, and pass the address of this declared variable. Right, and that will be used as its return code. So let's do that then. So exit. So whenever it exists with this return code, that is the same number that it has scanned while asking for the 8-bit number, right? Okay, so here it goes, like for the third question here, it says that the parent waits for the child to exit. That means like, okay, the child is exiting here, right? So the parent has to wait for the child to exit. So let's wait by using the wait system call. But okay, the situation is like we should declare a second header file that also declares include the header file for wait. Okay, so here it goes. So with this we can use the system call wait. I'll show you. Yeah, okay. So right now we can use the system call wait, and waits for the particular number. So you can also declare a different number. Okay, so let's check and declare a different number, that is like, okay, let's see that it's a code, and something like it's wait for that code, the address of the code is passed there. So lastly what it does is and displays it. It's written here that you have to display it. Retrieves, waits for the child to exit, retrieves the child exit code and displays it. So the exit code of the child is something like this. So it will be something like this. His child PID and exit shortly corrected. So let's print the child PID. Okay, let's see that this is parent that is printed just for understanding purpose. Parent then child PID something like this. Also create a new character here. Also a new character. Okay, so it would be something that is a PID, right? So after doing this, what it does, it exits. Okay, what we do right now is we try to run this. Okay, now you guys can run here. Like, okay, what is the 23? Okay, so there is something you guys have to understand. That is, the code that is passed can be any number. So it has to be 8-bit number. So you have to just append it with the 8. Now if you do something like that, now you compile, if you compile and run it. Okay, sorry, the situation is something like this. Okay, when you compile and run it, it will just print out something like this. So if you give any number, look, the exit code. So this 8-bit number was returned, right? And the exit, the same 8-bit number will be returned by the child, and this will be grabbed by the parent here. Okay, if you go and check out here, this will be grabbed by some, like I entered 23, right? So it was exited, and this was grabbed by the parent, and it printed out the same number. Same number was printed out here, and the child process ID is 6994. Whereas the child process ID also here printed out here 6994, and similarly it is okay. Now we were able to write this program. We were able to solve this program. So what I am doing is I am just trying to save this in a new file in this directory. So this it's just a Fort C file. This will be useful because it will be useful later on. Okay, yes, we created this file, saved it in this directory, that is lab 3. All the solution will be of lab 3 will be solved, like saved here. So now the question number 2 says something like this: compile and run the exercise 1 program. Once the program is running, do the following. So let's compile it. Before we compile using a code block, right now let's compile it using the GCC. So GCC file, then okay, let's say that my work. Okay, so let's see that the executable file is generated. Then okay, now the situation is, let's execute this executable file, my for. Okay, let's sleep for 4 seconds. Okay, now the situation is like, okay, there was some situation. This was like, it has to sleep for the seconds pass as the parameter, right? So there was some kind of situation which did not work well. It was sleeping. Just to print out and then sleep for 10 seconds. Okay, let's try edit this C file. Okay, so the situation okay, right now I edited it. Now let's see if it runs or not. Let's compare it again. Okay, so it generated the file. So let's pass the parameter 5. Yes, right now it's sleeping for 5 seconds. Yeah, after 5 seconds it's printed out this statement. So if I type any numbers like 3 2 34, yes, the same code was like cats. It was caught by the parent and it just displayed the same code that was executed, right? So we are done with it. So search the PID of the process using the PS command from the same cell using the run used to run the program and from a different cell. So now the situation is to do the process management, that is by using this command process. Yeah, this prints out the process ID, the terminal, the time and the command of this process ID, right? It generated the command that generated the process. So you guys can check out here. Okay, if you run a different terminal, different cell or different terminal, you don't need to put PS, it's the same thing. Okay, right now run 4 instances of the program in parallel using ampersand. You guys remember that previously I said that the foreground processes can be created by using the command, and at the end of the command you just have to use the ampersand sign. So okay, now let's try to run the program. 4 instances of the program. So let's look for 2 instances. Okay. So here I will show you all the practical concepts of how to use and just delete or terminate this process. Okay, it's coming just here, just to use this create the foreground processes. 1, 2, 3, and the 4th instance. Okay, yes, you guys see that 4 instances are running totally in parallel situation. Okay, enter any 8-bit number 1, 2, and all the process stop. Right now, this is use the PS to figure out all the process ID. So PS, yes. Right now, the situation is something like this. There are so many processes that are generated. Before, if I just this dash and the PS process. Right now, you can see that is the foreground process. They are running somewhere in the background. Is my for with PID 40, 41, 42, 43, 44, 45, 46, 47. So 7 new processes, 7 new background processes are just generated here, right? So it says now choose and terminate 5 of these processes from the same cell. So okay, now there is a command to terminate the background process, that is, as I showed you before, It was just kill minus 9 and process ID. Process ID you can get by using this command ps, and the process ID that you want to terminate is 7240. Okay, yes, if you check out the process ps now, yeah, 1 plus killed my 4 2, so there is no more 7240 that we terminated, right? So you keep on kill how much process you want, like 7241. Okay, let's check it out, the situation. Right now 7243 situation is there, so let's kill that. Okay, now almost we were successful to kill all these processes. So let's forget like background processes. So choose and terminate to terminate the other 5 processes. That means, okay, you guys can go to another terminal, just generate like this and just try by yourself. Okay, this is for your understanding purpose, because this is the same way, use the same way that I have displayed here, just to terminate any of the more 5 processes. This is your job. So now move to the different directory and run the program. So you guys can run in different way the program. Okay, for example, using the relative path. Okay, let's try. Okay, let me try going to the parent directory, and let me try to run this. Executable file. Okay, what I have to do is something here, somewhere here, and the executable file name is my fault, right? So let's sleep for this time. Let's sleep for like 4 seconds. Yes, by using the relative path, it is just working well. Sleep for 4 seconds. Now let's enter the number, that is 80. Yeah, here it is printed out as 80. Also, you can use the absolute path. You guys can use the absolute path. The absolute path starts from right click from this home folder, right? So this is for you guys to try it out. Or is also using a soft link. Okay, let me try to create a soft link for this particular file in this folder. Okay, in this lab directory. So as you guys know, for creating the link, that is the soft link, you have to use something like this command, and let's name the link, that is a soft link. Okay, maybe it has created a soft link. Yes, it has created a soft link with this kind of color, the different color. The soft link is created. Now you guys can also directly use this soft link, and this time let's sleep for like 6 seconds, and it's working properly. Okay, it's sleeping for 6 seconds. Now it's asking for the number. Let's give the number, that is something like 77. Yes, everything is working fine here, right? Okay, now let's go to our like very third session. Okay, that is write a C program which receives like 2 command line parameter, that is N and T, whereas the parent process has to initialize the counter, get 2 child processes and exit. Each one of the 2 child processes has to increment the counter, print it, and create again 2 child processes and terminate immediately after. And also it says that the process of creating the child stops after creating 2 to the power n okay, number of processes, and leaf processes, that is we usually call this kind of processes that is generated after, even if the children are called leaves. Okay, so for example you can see like if n is equal to 2, the parent creates 2 child processes and each child creates 2 other processes for a total number of 4 leaf processes. Okay, it's like something a child is creating children. These are like named as leaves, and there are something that is working in a loop, like something like. At this point, okay, process creation stops. So the last set of child processes like have to increment their counter and sleep for t seconds before printing it. So be careful. Each process creates 2 children processes, but only leaf processes are allowed to wait. Okay, so you guys can solve this kind of program in a similar manner that I have given, like I have taught before. And for this kind of problem, okay, that is creating such kind of more than one kind of child processes, and inside the child process are also there are some more child processes that are generated. And the basic idea is there is a here to solve a problem, such kind of problem, you have to use a loop, that is a for loop. So you have to understand that they have to create something like 2 children processes, and usually this is like parent also passed as a parameter, that is t. T stands for the time that it sleeps. Okay, and so each one of these 2 children processes has to increment the counter. So there is already a counter that is initialized to 0. So inside the child process you go and increment the counter plus plus. Whereas so process of creating the child stops after creating about n leaf processes. So also you have to understand this situation. Okay, now let's go through let's change the directory to lab 3 where we are trying to solve this situation. And what I am trying to do right now here is create this file, C file, for this kind of numerical problem. So the file is, I name it as a n children, but I can say for n child.c. Okay, what I have done is I have already created the complete file of the solution. Okay, I will just display and try to destroy first to save the time. Okay, what it says is something like this. These things are already clear for you guys, right? So we have like 2 processes, 2 child processes. So we define 2 kind of PID identifiers. Then similarly, these are also clear for you guys. You just grab the parameters and change it to an integer number. Okay, so this is the important concept that you guys have to understand, that is it's looping. That means n number of child that are passed as a parameter from here, okay, as argument. For that much number of children are produced here. Okay, and then similarly for PID1 you fork create children, and what you do is you check either is a child or a parent, right? Because you guys know the traditional technique to check this children, that is fork returns 0, increment the counter and print out the statement. right? So similarly inside the parent, that is you create a fork second time, okay, PID 2 equals to fork, you check again that is if it is a child or else obviously it must be a parent. Then lastly you execute, okay, exit 0, here the parent is executed, and you implement the counter, and then lastly you print out the statement. And here also lastly you print out the PID of the leaf that is going to sleep with the sleep system call just to sleep for the assigned value that is assigned as a argument, passed as a argument. Okay, this was just for your situations. Let's save it, let's minimize this, just close it. Okay, let's try to compile and run. Let's check out. Yes, we have this fork and child. Let's compile and run this. My fork and this object, the execution file that I'm creating. So let's see, yeah, it compiled very well. Now you guys remember that we have to pass like 2 parameters, that is number of children, that is 2 children, and let's sleep for like 5 seconds. Yes, it's sleeping for 5 seconds, so altogether it will sleep 5 like 5 5 5 5 altogether like 20 seconds. Okay, so it worked out very well, right? So because it printed out the PID, the parent, look, also the counter is printed out here like 1 2 2 2 2 and still sleeping. Process something is exiting, right? And the leaf, I'm going to sleep for 5 seconds, something like this. Okay, now let's try to run this one like you child sleep for 1 second. Yeah, you guys can see here something like it's sleeping for 1 second and everything is working fine here. And lastly, just get everything. Okay, so this was just about our last programming problem that we solved, and for summary, you already understood that how the fork works, right? And also you saw the parent-child relationship, and also understood how to call the fork. Okay, so the independent flow of execution is also there. So, and there is an independent flow of how the parent and child execute. They execute in parallel, but there is some kind of independence. Okay, they can execute anytime. You can just manipulate it according to your situation. Okay? Whenever you create the program, whenever you want. Either you want to execute the child first or the parent first. It depends on the program. So this was all the situation here. So thanks for listening, and hope to see you in the next new session. Okay?